So I'll give everyone a few more minutes to fill out this form while I tell you some of the stuff you can safely ignore about me. So my name's Ian Johnson. I go by Angelot on the internet. And here's my Twitter. I also put this page together fairly recently, which has all of my D3 related work. Namely, I've been giving some workshops. I'm giving one this Friday here. And while that one's sold out, I will be posting the materials online, and you can see the materials from the last workshop I did here. I also make I've made 3 of these mixtapes. They're short D3 coding videos where I do some live coding in like 5 minutes, illustrate some D3 technique and put it to a hip hop beat. And I also help run the San Francisco Bay Area D3 meetup. And we've recently, how many of you guys are from this area? A good amount of you. So you're all, familiar with BART, love it or hate it, but you know about the strike, and we put together a series of visualizations with members of the group, and that was really interesting. So that a lot of stuff using D3, using open data. So yeah, and this is a gallery of those projects. I guess the Wi-Fi here is kind of slow, but if you're at all curious, the BART strike was recently resolved, but if you're curious about the issues, like the high salaries, that kind of stuff, you can explore that data. So for today, I made this form. You can see that some of these questions are kind of like freshman college orientation questions. That's how I first heard the toilet paper, which direction does toilet paper go on the holder thingy. I don't know if you open this link on your phone, but apparently this can be a contentious issue, especially for couples that don't see eye to eye. But it made me think hey, we have a group of people here. I have a way, this Google form to collect data from you guys, and what better data to collect than harmlessly controversial stuff, right? So we can all look at this data and see ourselves in it and say, screw you crunchy peanut butter lovers, I like smooth peanut butter. Or, I drink pulp in my orange juice, I'm from Florida, how could you not? So then I also added a couple numerical scales, and I'm trusting you to self-report on your level of evil, which is not really, a proper surveying technique. But for today, what I really want to show is just how we can use D3 to visualize some stuff. So if you have some data that you can identify with and kind of find yourself in it, my hope is that it will make it easier to see the value of D3. I'm also asking how old you are, which can be a sensitive personal question, but feel free to put 0. Yeah, so let's see. I think, yeah, we got a good amount of responses so far. The spreadsheet's all filling up, so here's the data. So I'm going to go ahead and stop collection right now. It will still be available, but we're going to download this data as a CSV. Going to open it up, copy it. And yeah, before I get started, I'm going to use a tool that I've been developing called Tributary. It's a live coding environment in the web. Here's a basic example. This is based on Brett Victor's Inventing on Principle work. If you haven't seen that video or any of his following ones, you should definitely go watch it. But what this is a JavaScript. You can edit JavaScript on the right here. So this is all JavaScript and D3 code. On the left, it provides you with an SVG element by default. And then if you just click on any number, you can move it around, and it will re-execute the code. So this is showing different sine waves, and these are parameters that you would change in the sine wave. So you can code up stuff and then play around with it and explore parameter spaces can also change the colors. So that's the top one. So this is a handy tool for prototyping D3 projects. I use it all the time to test an idea out. I learn about some new SVG technique, throw it in here real quick. I don't need to create a new index.html and all that stuff. It's all open source, so you can check it out if you'd like, if you're interested. So but what we're going to do is start a new one. And I'm going to paste the CSV file. So D3 actually provides you a method, d3.csv, to download CSV files from the internet. And this is being really slow. But Tributary provides you a way to input that by default. So if I prepared for this because I was warned that the Wi-Fi might not be fast. I also, just in case that we couldn't collect the data, had some from a Twitter survey. So anyway, here's a survey.csv file. You can see we have like the time that the data was collected, all the answers. These, the headers of our CSV, if we were to go here, make this big so you can see it. All right. So our CSV has these questions, right, from the form. But if we want to programmatically access our data, and we want to say, you know, for every one of you, you answered, you know, peanut butter. I don't want to type, you know, data dot what type of peanut butter do you prefer, just so I can get the value of your answer. So we're going to change that. And I prepared this ahead of time as well to kind of save time here. So you can see that this set of code is not really any of it material to D3. It's more convenience for our data processing. So now the header of my CSV file looks like this. So the first question is peanut butter, so it's PB. And so now my data, when I do this, if I look at this object, you see PB is smooth. So I can do, you know, data D here. And then also CSVs have everything represented as text. So I'm changing some of the values to numbers here. And there's also another thing I prepared to up the font size. Just pretend like you're not looking. Oh, that should have worked. So, yeah. The other thing I've done here is made this QMap thing, because we will want to relate our data back to the original questions, right? Because data visualization is all about communicating with people. So we need to manipulate it with code to be able to represent it. But at the end of the day, we want to be able to show people a graph or a visualization that it relates back to the original questions. So before I go any further, there's another thing I wanted to do during this. I'm trying out this crowdsound.io. I believe if you go to crowdsound.io/beta, you can find this HTML5 devconf room. And then I've asked a couple of questions, and then you can also ask me questions. So I'll periodically check this, because I'm going to create some visualizations on the fly here. We're going to explore several aspects of D3's API, and D3's API is way bigger than I could possibly cover in 40 minutes or even hours. So, I'm going to go down the paths that I sort of like, but if you get really curious about something, or if you want me to expand on some aspect, this would be a good way to try to poke me about that. Also, before I get any further, I should mention a couple words about D3. For those of you who are not intimately familiar with it, It's a toolkit. It's not a charting library. It's fairly low level in terms of if you want to create a visualization, it gives you all the Lego blocks, the building blocks to put together, but it does not really, you don't just set some parameters and it spits out something nice. It's actually really powerful to start embedding visualizations inside, web applications and websites. And, these are a couple visualizations of the D3 API. So this one on the left is a kind of more general one where showing how many functions there are in each of these broader categories. So the core of D3 is this concept of selections, which I'll talk about briefly. That actually takes a long time to internalize, but you can get going pretty fast. Scales we'll use a lot throughout today, and they're one of the more powerful tools in the tool belt. Layouts we'll cover a little bit of, the cooler one, the force layout. SVG, so D3 actually it stands for data-driven documents. You can manipulate HTML, SVG, even Canvas, WebGL. But a lot of what it's built for is building data visualizations with SVG. So there's a lot of SVG helper functions. There's also transitions and a bunch of other stuff. And this is how all the functions tie together. And if you click on this, you can explore that more. So to me, D3 it's a little bit like alchemy. You're probably familiar with the expression that any sufficiently advanced technology is indistinguishable from magic. But I like thinking of it as alchemy more because it's this sort of pseudoscience where when you start to kind of grasp some of these magical things, you can actually do a couple of them, but still someone else comes along and they just, perform some magic. So the main recipe in this alchemy is the selection stuff in D3. So the way that works is that let's say I have a div called display, and I've selected that already. So just like jQuery, you could do, if you do display in jQuery, right, that selects the div with the ID display. The equivalent thing in D3 is d3.select. Right, so that should be pretty easy to get over. But then there's this select all thing. So here I'm selecting all the divs that have class person. But let's say I don't have any divs on the page yet that have class person. I can pass them data, and then with this enter and append, I can create those divs. And it will create one div for every piece of data I have. And so it's like binding the data to the DOM. If the DOMs are bodies and the data is souls, right, you perform this alchemy. And then you can set style or element attributes using this kind of syntax. And I'll be demonstrating this in a second here, so I won't talk about it as much. So let's just demonstrate it. So if we have all of our data here, I've got it as in this results variable. So because I have this file named survey, I can get the data as tributary.survey, and that's an array. If I log out the whole array, it's you can see this long array. It's got 56 survey responses. If I open some random one, you'll see that this 26-year-old is fairly similar to me in terms of pulp and smooth here. So yeah, we can click around and poke around the data, right? But we could just use Excel to do that. So let's actually make some of these DOM elements. Another thing I'm going to do is I'm going to switch to HTML mode in here. For the most of today, I'm going to use SVG and demonstrate, the fun visualizations. But I want to start with generating HTML because that's probably more familiar to everybody. And we can. So I'm going to select that display. I'm going to do the code I had before. In fact, instead of typing it out, so I've created a little green rectangle. I can change the color for every person. And that's all well and good. Where's my clear thing here? Clear the console. But what I want to do next maybe is just kind of confirm that that's the data. So let me add a click event. So just like jQuery or other things, you can just add this on handler. But what this does is this adds stuff to every single one of them, right? So this people variable is kind of like an array. It's D3's selection array. So any action you take on it will happen to each one of these elements. And with any function like this, where I'm saying, you know, anytime any of these are clicked, when it's clicked, it will call this function, and it will pass me in 2 options. And this is something you'll see a lot. So let's just say I log those out. So if I click on this one, it will spit out this data object and give me that information. So this is, you know, it's okay. We have, let me inspect these elements so that you can kind of see. So if I inspect one of these guys, right, I created a div, it has a class person, it has the style set to what I did. So I'm, you know, also to note here, I'm programmatically setting the style, but you could use CSS, you know, instead of doing that. But it is nice for doing data-driven styles, which we'll get to next. So the next thing I want to show or talk about is scales. So scales are, there's a few different types that we can make use of, and the first one we'll try is a color scale. So let's grab this over here. And with a color scale, I'm going to put this kind of above where I start rendering stuff. I'm saying this is an ordinal scale, so that means things that are in order, or you know, you can also think of it as categorical scale. So for every member of this category, I'm going to say, well, for crunchy, I'm going to make that white, and for smooth, I'm going to make that black. And if I had more answers or more options, I could just add those here, you know, jelly, and then I could give that a color. And so then what this does is it creates a function, this color scale. If I console.log color, and I say color scale, and I pass it smooth, it's going to give me back this hex value for black, right? And if I pass it crunchy, it gives me back the value for white. So I want to actually show the values here. I want to, you know, the answers to this question. So let's do that. Instead of setting the background color to this, you know, random color I chose, we can actually pass in a function with D and I, which, just like this onClick handler, gives us the data for each one. It's not showing anything right now, but if I make them all red, let's say, or I can pass back color scale, and then I would do d.pb. So now this is showing the, I should do this. You know, everybody's answers. So again, black was smooth, white is crunchy. Of course, you probably want to sort the data so that you can, you know, get everything grouped together and see that much better. So let's do that up here. So this is a standard JavaScript thing where you pass in, you call sort function on array, pass in 2 items. And I'm going to say if b.pb is less than a.pb. And I always forget which one comes first, 1 or -1, to make it sort ascending or descending. But anyway, now they're all grouped together. So if we want to keep going down this road for a little bit, okay, it's great. We can see, peanut butter. We can click, or we can type that in everywhere. Maybe I want to make a field, and I can change that. And this way, we can quickly check out the different answers. Where else did I use it? Okay, so now if I change the field to OJ, looks like most people, oh, of course. So here's a problem, right? I'm changing the answer, but I'm using the same scale I had before. So I've actually gone ahead and prepared something for this. So beforehand, I made this questions thing here. Oops. So let's do this. Since I set up this form, I knew which questions I was asking and which fields are the categorical ones. And then here, I'm going to pull out the domain and do this programmatically. So now I'm saying, look up in this dictionary for the field that I'm using. Give me the answer options, right? So I prepared that ahead of time. So this is something I'm doing a little bit different from the last time I did this kind of talk. I'm preparing the data more ahead of time rather than doing it in front of you guys. The trade-off is that I want you to know that preparing data and manipulating data is actually the hardest part of data visualization. It's the most time-intensive, the most laborious thing. Once you have data in a nice format, at least for me and a lot of people I know, the visualization is the fun part. Like that's the reward. Really getting this kind of stuff set up so that it's not, whatever Google Forms spat out. And, luckily this time I also figured out Google Forms validation, because last time people were putting in crazy answers to throw me off and stuff. So this time, I can just relate that to you instead of struggling through it. But here we are doing this color scale. So now every time I change this field, and instead of doing it even like this, I can say questions 0, 1. So in terms of toothpaste, so now we get to something, right? I can play with these and start talking about results. But, oops, how do I do that? Should not do that anymore. So it's one thing to put stuff on the screen, right? But we can't read this. We can't read these charts. So let's put up a simple legend real quick and just get that on there. And so I'm going to build this legend programmatically. This is not necessarily the most efficient use of D3 to build something like this, but I want you to see, that everything that you're used to doing, writing it out by HTML or maybe doing it with templates and handlebars, you can also do at D3, and then you can choose which parts you want to do using this tool and which parts to do with another tool. So I'm going to make a div. I'm going to call it, give it a legend class. And then I can add, a div for the answers. And so I'll append one div that I give. I'll just copy this style. This is supposed to say true. And then here, this will just be QMAP field. So I'm going to grab the first one I can also quickly add a style thing here, and I'll say legend. And then maybe I want to each of these append, I don't know, a span, set the text to QMAP. Oops. Let's set this width to 100%. Oh, sorry. I want to make this the text, the answer. Maybe style this. So you can see pulp and no pulp. And then here I'll do the question, right? So now as we change the fields, we can make a little more sense of it. So it looks like more people squeeze out of the top of the tube, which, you know, that's my team. I don't know about you guys. Are you guys like saying anything here? No questions? Okay. Yeah, so, you know, part of this, like, I'm trying to appeal to your tribal nature. So, like, we got to, you know, stick together, top the tube squeezers. Man, so many crunchy, I'll get it. Vanilla and chocolate, neck and neck. Oh, those poor few under here, huh? Sorry. Mostly pulp, all right. All right, so, you know, now we can see this, like, divide here, but I'll come back to this kind of this visualization, but I want to break off now and start dealing with some of the other scales. And so we're going to switch back to SVG. So I'm actually just going to go ahead and I forked this, which like made a new copy. If you're curious, you know, you can go to this address. You can also, if you just go to Tributary and somehow find, like if you go to one of mine and go here, it should load a list of all the ones I've made. So the ones I'm making now will show up in the front here. And actually, you know, prepared ahead of time just to be safe. And so if you want to click and play around here, or, you know, later peruse that, all that code is available. So we're safe to, oops, I meant to delete that here. Let's get rid of all of this. We still have the data preparation we've done. I'm going to switch over to SVG mode. So the first thing I'm going to do is I'm going to just try to make a bar chart. I want to see how evil you guys are. I mean, I'm standing in front of this crowd, right? Who knows what you're going to do? So let's find out. So let's grab the SVG. So in Tributary, by default, I've provided an SVG element, so you can just select that tag. In your own projects, you would, you know, make a tag SVG in your document and then select that. I'm going to select all, instead of divs, I don't know how familiar you guys are with SVG, but there's rectangle objects, which are much like a div, but their whole main purpose is to draw rectangles. So I'm going to select those. I can also call that person. So let's use the same terminology here. And then I pass it the results as the data. I can enter. So enter means anytime that you selected a div or an element that doesn't exist but you have data, it will execute the code that follows it. So this will be, I'll append direct. I'll set as class true. Let's get some more room here. So then in SVG, you can set attributes instead of styles to do style-like things. So if I set width to be 100 pixels, height to be 100, we'll see it show up. There's a convenient thing where you can actually just set X and Y coordinates instead of saying top and left. So this is creating a rectangle in the same place for every single one of these things. Because in HTML, right, divs will just kind of lay themselves out. But in SVG, it doesn't do flow calculations for you. So it's just a XY coordinate space where 0, 0 is at the top left. And you have to tell every single one of these rectangles what to do. So one thing I might do is make them a lot narrower. Maybe start them over on the left. And then I can do this function thing again. If I just return one number, they'll all be the same. But let's say I can use, I times 15. Let me just close this for now. So I can play with this number, right, to do their spacing. If they're spaced like that, they're too wide. Now let's say I want to, so I'm fairly happy with these bars, but they don't represent anything. So I want to see how evil you guys are, right? The first thing I should do, really, is calculate the extent of your evilness. And so D3 provides a few methods. Extent is one of them. There's also max and min. Extent basically it finds the max and the minimum and returns it in one array for you. So if I say results and I pass it a function, I say, give me the extent of the evil parameter. Let's see what that is. Wow, you guys ran the whole spectrum, 1 to 10. Who's 10? Watch out, whoever's sitting next to them. All right. So we know we ran the whole spectrum. Now let's say we want to make the height of our bars, the height of each rectangle, represent how evil you are. Then I could just do but this doesn't really look that great, right? It's just tiny little rectangles, hard to read. What we really want to do is scale these values, scale the evil to be a pixel representation on the screen that's readable and that, that will always work no matter what the input is. So in the slides, I prepared a linear scale, which here you can see I've manually done 1 to 10. We can also put the extent array here. And then the range is saying, basically for values that are 1, I want my bar, I want this to spit out 0. For a value that's 10, I want it to spit out 400. And it's a linear scale, so a value that's 5 will spit out 200, which is halfway between 0 and 400, right? So instead of just returning d.evil, I can return a linear scale of d.evil. And now I have something actually readable. And maybe I don't want this to go from 0 to 410, maybe like that. But now my bar chart's upside down. So we can also, one trick for that is to return like the maximum number we were going to use and subtract the linear scale. And this is, a little bit of math when you know this trick. Maybe we want to move it down a little bit. But it's a lot less math than you'd have to do if you were manually calculating these scales all the time. And it provides a really convenient interface. And at any given time, you can swap out this range or the domain programmatically and so reuse a scale. So that's a basic linear scale. I want to also quickly show a time scale because while today's data is not really that interesting from a time perspective, like you guys all filled out the survey within the first 5 or 6 or 10 minutes leading up to the talk, But let's check that out anyway. And you know, I want you to be aware of the timescale API because it is very cool. So here I've done the extent thing already. I should sorry, I'm going to try to pump this. There we go. Now we have a slightly bigger font size. Maybe you guys can see that better. Anyway, so here's my time scale. I'm grabbing d.time, which is the variable that had that. And I'm also scaling that from 0 to 400. Let's scale it to 500. But so let's say instead of putting each of these on the x-axis, like spacing them like this, we'd say time scale d.time. Whoa, it looks like they're super bunched up. Oh, I know why that is. These first two I filled out last night while I was testing. So now it's more spread out, like some, you know, early bird today, and then they're more filled out here. We can maybe thin the width a little bit. If we also give a fill opacity that's not 100%, we can maybe see the stacking up a little bit. So okay, we have our linear scale, color scale, time scale. It'd be really nice if we knew, if we could see what these scales were, you know, representing, right? So D3 provides an axes component. So axes are part of this SVG generator part of the API, where it will create some SVG for you. It doesn't even style it. You have to do that yourself. That's why all this crap is here. I prepared it because it's boring, but it's basically like setting some default colors to it. But, you know, so a lot of people misunderstand this because they're like, well, you know, I just want my chart to come out and have like these kind of tick and like axes with these numbers on it, and what settings do I change? A lot of this is about generating the SVG and then using the same tools you're using to build your visualization to manipulate what's been generated. And what's been generated has data attached to it already. And so let's take a look at that. So I'm just going to straight copy this into here, because this is already assuming a time scale. And I'm going to move this up. So already our scale is a little too wide, I think. So let's take a look at this code. So ignoring this format thing for a second, we create this axis object, which is actually a function. So a lot of things in D3, you generate a function that then does stuff, and then this is how you set the parameters. So we tell it to use the time scale, and then we orient it to the bottom. If we, you know, change this to top, it would have the ticks on top. We can suggest how many ticks we want. So I said 5, but it's only giving us these few. If I say 10, then it gets all messy. And then I've provided a tick format, which you can look up d3.time.format in the API docs. In fact, this is such a common search in my browser that this is the first thing that comes up. So I highly recommend anyone, you know, using and playing with D3 to do this search all the time. And the internet's being slow, but yeah. So these are all the methods, and if we search for time.format, you can click there and see how, like, all the ways that you can format time. So this is pretty convenient. Definitely, you know, part of the reason this is a Swiss Army knife. We can also do fun stuff like, let's say we put back these 10 things, right, and they're all bunched up. I'll give you a little bit of a taste of manipulating this stuff, right? So This actually, why don't we inspect the elements for a second? One of these ticks, axis ticks, is a group element. So in SVG, a G stands for group, is like a div. It's an empty container. It's actually even more empty than a div. You can't style it. You can't change the way it looks. All it does is act as like a way to group other things together. So if you're familiar with Photoshop or Illustrator or those kind of things, it's how you can create layers. So, but you can move it around, which is why it has this translate thing. And then inside each of these, there's a line and a text. So what I want to do is I want to select all of the ticks, the text of those, and I'm going to change the transformation. I'm going to rotate them. But then I can also translate. And then fiddle with this until I like kind of how it looks, right? So, just because it gives you something in one format and laid out in one way doesn't mean you can't go in there and make it act like you want it to. All right, so another generator, which is a bit more complicated that I've prepared, is a brush. And I will copy paste this in and show you what it does. So this is a case where you have it generates some SVG that also does stuff. So I can like click and move this and move this stuff around. But let's actually see why you want to do something like that. Aren't these the cutest little cups? Yeah, like 3 up here. Okay, so a brush, you also give it a scale. So I'm going to give it the time scale again, which I'm going to move over here. It generates these like rectangles and stuff. So all of this code down here is just me styling the brush, the SVG that it generated. If I get rid of all this, it just doesn't show up because by default it's hidden, and so it's really up to you to generate all that. The thing that I want to be able to do with this is the brush generates events. So it generates a brush event. And what I can do is I can get the extent of the brush, which is actually going to be in terms of the scale that I gave it, right? So if I do this, it's giving me 2 dates, the min and max date for that. And what I want to do is I'm going to select my rectangles. Or did I already save them as people up here? And I'm going to style their fill to be black, which they already are. But what I want to do is be able to select the rectangles that fall in a certain time range with this brush and change their color. So I can filter and then if I'll return d.time is greater than the beginning of the extent and d.time is less than the end of the extent. And then I can style this red maybe. Yeah. Seems to be offset by a bit. Oh, I think my people are not offset by the same amount. Cool, so there you have a brush. Do those things. Now, does anyone know how much time I have left? 5 minutes. Wow. Okay, so let me just quickly peruse the code that I've prepared in advance. We went through this linear scale, went through the time scale. I wanted to show a scatter plot where, we had passion and evil, and you could compare, so if you're really passionate and evil, you're like a supervillain. If you're really good and passionate, you're a superhero, right? And see where people fall. The problem with that is that we used a very, a scale, 1 to 10, no decimals, not very continuous, so everyone will overlap here. So you can use the force layout, which is somewhere around here, that would, this is the same as a scatter plot, but they kind of, it's not precise, right? But you can see where people are bunching up. So I believe it was like passion and evil. So my Twitter following is not, it's not very good. And then finally, there's something you can do with SVG. You can actually, so I prepared all these, or actually a good friend of mine, Sarah, made these icons for me to represent the, the different possible answers. And I made a plugin called d3.sticker, which allows you to take any piece of SVG and copy it and then paste it as much as you want programmatically. So here I set it up so that if we, like before we were doing with the colors and answering these questions, oh man, this is just like slightly too low res if I make these. Okay, so now I can actually click on these in the legend and see the answers represented iconically. And this legend is actually, this code, which is not much more code than what we wrote just to make one legend item, but it's all data driven and using those events. So yeah, sorry I couldn't live code all of that in such a short amount of time, but I guess I can take a couple questions before I get pulled off the stage. Anybody? Yeah.
So it's pretty basic, right? So the data call does the mapping and it looks at the entity that is the parameter for the class things and maps it to the nodes that exist, what's coming in, is that right?
Yeah, so it will either map it to an existing node, or if there isn't an existing node that matches, it will allow you to create a new one. And also, if you have a smaller data set, it will let you know when there's like nodes that no longer have data, so you can remove them.
So if you have an external process that changes the data, then something has to invoke
You call those functions, and you can so with one set of code, you can handle data being created, added, removed, or updated. So you don't have to rewrite that for different cases, is the power.
I mean, something has to call it, right?
Yeah. You have to know that the data changes. So there's talks online from our meetup group of people using D3 with Angular, with Backbone, all these other frameworks that you can mix with D3 for sure. Cool. And yeah.
Compare and contrast D3 and Canvas and when you would use either one, which is one is appropriate for this, one might be more appropriate for that.
It's actually the comparison would be between SVG and Canvas. You can handily use D3 with Canvas. Many people do. That force-directed layout, this is rendered in SVG, but I could just as easily draw circles instead of SVG, like arcs in Canvas instead of SVG circles. You want to use Canvas when you have to draw a lot of things and you don't need as much interactivity. SVG makes it really simple that you could like click or drag or do anything on these elements, and you don't have to do any special calculations to know what you're clicking on. It's just like divs or anything else where the events are just set up there for you. So it's a rendering performance versus interactivity trade-off, but D3 can do both. It's a toolkit that can talk to either one. Cool. Yeah. So WebGL is more like advanced Canvas, and it can, it has all this 3D stuff. Somebody I just met a couple of days ago is working on a thing that will render D3 calls into WebGL Canvas for you to speed up performance. So yeah, it's a spectrum there, but. All right, well, thanks, guys.